everyone. This is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in the Institute of Aeronautical Engineering, Dundigal. In this lecture, we'll discuss about the transistor hybrid parameter model. That is, first of all, what is a hybrid parameter model? What are the various types of parameters we have, and why we are going for the H parameters, and how we can approximate a transistor, or else how we can draw the equivalent circuit of a transistor using hybrid parameter model. We'll see in this lecture. So before that, first of all, as we all know that the transistor is a 3-terminal device. So where it can be approximated as a 2-port network. So what is a 2-port network here? So a 2-port network is an electrical network or electrical network model with one pair of input terminals and one pair of output terminals, and it is mainly used to model the voltage and current characteristics of complex electrical networks. So here, this is the block diagram of 2-port network. So where we have input port and output port, where the input port is represented with 1 dash, and the output port is represented with 2 and 2 dash. So our aim is to approximate a transistor as a 2-port network. Why? Because we have 3 terminals in a transistor, and in the 3 terminals, one terminal is considered as common, and the other one terminal is considered as input terminal, and other terminal is considered as output terminal. Based on this, we have 3 configurations. So that is why a transistor can be considered as a 2-port network. That means we can model a transistor as a 2-port network by considering one of the terminal as input and one of the terminal as output, and the third terminal is considered as common between the input and output terminal. So that means we are going to apply the input to one port and the output is taken from the other port. So there are various parameters needed to analyze a 2-port network. So what are the various parameters we have? The parameters that we can use for analyzing a 2-port network. What do you mean by analyzing? Analyzing in the sense calculating the various characteristic parameters of a 2-port network, like impedance, admittance, voltage gain or current gain, like that. So for analyzing this, we have various types of parameters. Those are Z parameters, Y parameters, H parameters, G parameters, ABCD parameters. So these are the various types of parameters. Now let us see basically what is the difference between Y, Z and H parameters. We are not concentrating on G and ABCD parameters. We are going to see what are Z parameters, Y parameters and H parameters. Why only the H parameters are used? For modeling the transistor as a 2-port network. So first of all, Z parameters. So what do you mean by Z parameters? So Z means impedance. We all know that Z is impedance and Y is admittance. So Z parameters are also known as input parameters. And when we use Z parameters for analyzing a 2-port network, the voltages are represented as a function of current. So in the last slide, we have a 2-port network, right? So let us consider this as the input port and this as the output port. So we do have input current. That means some current will be flowing in the input port, and also there is some voltage applied to the input port that is represented with V1. So, and similarly, there will be some current flowing through the output port that is represented as I2, and the voltage across the output terminal is represented as output voltage, which is represented with V2. That means we have input parameters. What are the input parameters we have? V1, I1, input voltage and or input current. And similarly, we do have output parameters. What are the output parameters we have? V2, I2. So V2, I2 are the output parameters which are measured at the output port, and V1, I1 are the input parameter which are measured at the input port, that is port 1. So here we have various types of parameters. As I said, Z parameters, Y parameters, H parameters, and so on. So here, the Z parameters are mainly calculated. So whenever we are calculating the Z parameters, so always we have to remember the voltages are represented as function of currents. So among the four parameters, what are those? Input voltage, input current, output voltage, and output current. Any one of the two are expressed as a function of the other two. And that means any two of the parameters are considered as dependent and the remaining two are considered as independent. So here, in case of Z parameters, so the voltages are represented as a function of currents. So that means the current I1 and I2 are considered as independent parameters. Independent parameters where V1 and V2, that is the input voltage and output voltage, are dependent variables on which these parameters are depending. So these parameters are depending on the currents. So that means I can express V1 as a function of I1 comma I2, and similarly V2 is also a function of I1 comma I2. So that means what I want to say here, so the voltages are represented as function of currents, where the currents are considered to be independent, where the input voltage and output voltage are considered to be dependent variables which are depending on the currents here. So that means we can say that the voltages are expressed as function of currents, that is I1 and I2. By considering this, we can define four parameters. What are those parameters? So here we can have before this, so let us go to the next slide. So we can have as I told you that V1 is a function of I1 comma I2 and V2 is also a function of I1 comma I2. Now how can I express this V1 and V2 in mathematically? So for that, V1 is equals to Z11 into I1 plus Z12 into I2, where Z11 and Z12 are constants. So these are the Z parameters, Z11 plus Z12, and similarly V2 can be expressed as in terms of currents as V2, which is the output voltage measured across the port 2, that can be represented as Z21 into I1 plus Z22 into I2. This is the mathematical equation which is showing the relationship between, or else the mathematical relationship between the currents and the voltages. So now here these are the basic equations. So here now, and these parameters, these set parameters are also known as open circuit parameters. These Z parameters are also known as open circuit parameters. Why these are called as open circuit parameters? So as I told you that we have two equations. What are the two equations we have? V1 is equals to Z11 into I1 plus Z12 into I2, and similarly V2 is equals to Z21 into I1 plus Z22 into I2. These are the two equations, right? First equation and second equation. Now I said you that these Z11, Z12, Z21 and Z22 are the constants or else parameters. So how can we calculate this? So here, these are also called as open circuit parameters. Why we are calling these as open circuit parameters means, so I can calculate Z11 and Z21 when I2 is equals to 0. Making current equals to 0 means what? Making that particular port open circuit. Whenever the current is 0, it means that it is open circuited. Whenever the voltage is 0, it means that it is short circuited. So I2 means what? It is related to the port 2. So that means when the output is open circuited, you can be able to calculate the parameters which are Z11 and Z21. So how can we calculate? If for the case 1, if I2 is equals to 0. If I2 is equals to 0, then what happens from the first equation? V1 is equals, this term becomes 0. So Z11 into I1. So I can calculate this Z11 as V1 divided by I1 when I2 is equals to 0. So that is the first parameter. Z11 is equals to V1 divided by I1. So as we all know that the ratio of voltage to the current is defined as impedance. As both the parameters are related to the input port, so we can define the Z11 as the input impedance keeping output port open circuited. So that is Z11 is the input impedance keeping the output port open circuited. Similarly, from the equation 2, if I2 is equals to 0, what I'll get? V2 is equals to Z21 into I1. So I can calculate now Z21 value, which is equals to I2 divided by I1 by keeping I2 is equals to 0. So that means here, what is this ratio? This is also impedance because it is a ratio of voltage to the current. Voltage to the current is defined as always impedance. But here, it is measured between V2 means output port parameter, whereas I1 is the input port parameter. So that is why we can call this as the forward transfer impedance. This is the forward transfer impedance, which is measured between output voltage and the input current by keeping output open circuited. So Z21 is the forward transfer. Why we are calling it as transfer? Because it is measured between the output and input port. And why we are calling it as forward? Because always you must consider any ratio should be calculated between output and input. Then it is called as forward. If it is measured from input to the output, then it is called as reverse. So, as we are measuring this parameter between the output voltage and the input current, so we are calling this as forward transfer impedance by keeping output port open circuited. Why I am calling it as output port open circuited? Because I am making I2 0. I2 is related to what? It is related to the output port. That means making output current equal to 0 means making the output port open circuited. So, this is the case. Now, when I take I1 is equals to 0, if it's for the second case. Now from equation 1, what I'll get? From equation 1, what I'll get? V1 is equals to, as I1 is 0, first term gets 0, becomes 0. And that is Z12 into I2. Now I can define Z12 as V1 divided by I2. So what we are doing? We are taking I1 is equals to 0. So Z12 is the impedance parameter, which is the reverse transfer impedance. Why we are calling it as reverse transfer impedance? Because in the numerator we have input parameter, whereas in the denominator parameter we have output. So that is why Z12 is called as reverse transfer. Transfer means this impedance is measured between the output parameter as well as the input parameter, not both input or not both the output. So that is why reverse transfer impedance keeping input open circuited. And similarly, from equation 2, what we can have? From equation 2, we can have V2 is equals to Z22 into I2 by keeping I1 is equals to 0. So, I can say that Z22 is equals to V2 divided by I2 when I1 is equals to 0. So, these two are the output parameters only. So, and it is defined as a ratio of output voltage to the output current, and hence we can call it as output impedance when input port is open circuited. So, these are the 4 Z parameters. So, which we can calculate from the, which we can calculate by either open circuiting the input port or by open circuiting the output port, and hence these parameters are also called as open circuit parameter. So, we can also represent these two equations in the form of matrix. So, as this. So, V1 and V2 are the two equations. So, that is V1 and V2 as a column matrix equals to Z11 into Z11, Z12, Z21, Z22 into I1 into I2. So, these are the column matrices. These are the column matrices, and this is a square matrix which is having 2 rows and 2 columns. So, this is about the Z parameters. Okay. So, now coming to the Y parameters. So, the Y parameters are also called as admittance parameters, and when we are calculating, as I said you that in case of Z parameters, the currents are considered to be independent and voltages are considered to be dependent. But here in this case, it is reversed. So, that is currents are expressed in terms of or else as a function of voltages V1 and V2. So I1 is a function of V1, V2, and similarly I2 is also a function of V1 and V2. So now how can I write these equations? So I can write the equations as, so from this I can write the equations I1 is equals to Y11 into I1, Y11 into I1 plus Y12 into I2. Similarly, I2 is equals to Y21 into, sorry, it is V1. Just a second. Okay, this is V1 and this is V2. Okay, so this is Y12 into V2. Now Y11 into Y21 into V1 plus Y22 into V2. These are the two equations. So now these are also called as short circuit parameters. These are also called as short circuit parameters. Why we are calling these as short circuit parameters? Because I can calculate these Y parameters. Those are Y11, Y21, Y12 and Y22 by making either V1 0 or V2 0. So making voltage 0 means short circuiting a corresponding port. So that means either we are short circuiting the output port or short circuiting the input port. So in order to evaluate these Y parameters, either of the port must be short circuited. Now, first case. Now the case 1. So when I take V1 is equals to 0, then what happens from the equation 1? From equation 1. So let us consider this as equation 1 and this as equation 2. So from equation 1, so what happens? I1 becomes, so when I consider V1 is equals to 0, so this first term becomes 0. I1 is equals to Y12 into I2. So now I can define I12 as I1 divided by I2. This is V2, right? I1 divided by V2. So this is the Y12. So that means as Y12 is a parameter which is measured from input to current to the, it is measured as a ratio of input current to the output voltage when the input port is short circuited. So we can call this Y12 as reverse transfer admittance, and by keeping input port as short circuited. So that is Y12 is equals to I1 divided by V2 into V1. So as we all know that admittance is the inverse of impedance. Impedance is measured as a ratio of voltage to the current. So admittance is measured as a ratio of current to the voltage. So as it is the ratio of input current to the output voltage, so we are calling it as reverse transfer admittance by keeping input port as short circuited. And similarly, from equation 2, what we can have from equation 2, we can have I2 is equals to, so as V1 is 0, so first term will be 0 and second term Y22 into V2. So now from this one, Y22 I can calculate, that is V2 divided by I2 by keeping V1 is equals to 0. So that means as it is a parameter measured as a ratio of output voltage to the output current, so I can define Y22. So I can define Y22 as the output admittance keeping the input port short circuited. So which is defined as I2 divided by V2 by keeping V1 is equals to 0. And similarly from case 2, what we have to do? The case 2 is we have to take V2 is equals to 0. When I take V2 is equals to 0, then I can calculate from equation 1. From equation 1, I can calculate a parameter Y11 which is equals to V1 divided by I1 by taking V2 is equals to 0. So that is why it is a ratio of input voltage to the input current to the output input voltage. So here this is input current I1 to the V1. So it is defined as the input admittance by keeping output port short circuited. And similarly, from equation 2, what we can calculate? By taking this V2 as 0, so I can calculate Y21 which is equals to Y21 is equals to I2 divided by V1. So it is defined as a ratio of output voltage to the input current. So it is also called as forward transfer admittance by taking output port as short circuited. So these are the Y parameters, and these parameters are calculated by taking either input port by considering either the input port as short circuit or output port as short circuit, and these parameters are also called as short circuit parameters. Okay, so these are also can be represented in the form of matrix. So that is I1 I2 is the output, whereas it can be expressed as Y11 into Y12, Y21, Y22, and a column matrix V1, V2. So this is the matrix representation of Y parameters. So again, these two are the column matrices, whereas this is the Y parameter matrix, with this is the square matrix. So those are the Y parameters. Now coming to the H parameters. So here, now let us see, we have seen all these parameters, right? As all these parameters are admittance parameter, all the parameters will be having the units as mhos. So the Y parameters are having the units as mhos. Okay. So mhos, and Z parameters are having the units of ohms. Okay. So that means we have 4 parameters, Z11, Z12, Z21, Z22. These are all the Z parameters which are having the units as ohms, whereas the Y parameters are having the units as mhos, because these are defined as a ratio of current to the voltage. So that is admittance, and the units for admittance are mhos. So now let us see the H parameters. H parameters stands for hybrid parameters. So hybrid parameters are so called because they have Z parameters, Y parameters, voltage ratio, and current ratio. That means this is a mix of these are the parameters which are the mix of impedance, admittance, and transfer ratio parameter, that is voltage ratio or current ratio parameters. So that is why we are calling this as hybrid parameters. So if you see the Z parameters, all the parameters are having unique units, those are mhos. Whereas for Z parameters, all the 4 parameters are having the units as ohms. Whereas coming to the H parameters, the parameters are mixed. We will have Y parameters, Z parameters, and also voltage ratio and current ratio. So these are the mixed parameters. So that is why we are calling this as hybrid parameters. And here in the previous cases, so in Y parameters, Z parameters, we have considered the currents as a function, so voltages as a function of currents. Whereas in Y parameters, we have considered the currents as a function of voltages. But here in this one, the input voltage and the okay. Okay, so input voltage V1, and the output current I2 are the independent parameters. So let us have here, so I2 and V1 are the dependent variables, whereas I1 comma V2 are the independent parameters. Independent parameters means what? These are not depending on any other variables, whereas the input voltage and output current are expressed as a function of input current and output voltage. So that is V1 is expressed as a function of I1 comma V2, and similarly I2 is also expressed as a function of I1 comma V2. So now I can write, based on this, I can write the expressions as these are H parameters. We will be representing them with H. So I can write the expressions as V1 is equals to H11 into I1 plus H12 into V2, and I2 is equals to H21 into H21 into I1. This is H21 into I1 plus H22 into V2. So here we can write V1 as a function of I1 V2. So that is H11 into I1 plus H12 into V2. Similarly, I2 can be expressed as H21 into I1 plus H22 into V2. So these are the expressions here. So H parameters are mainly used in describing the input and output characteristics of circuits where it is hard to measure the Z or Y parameters. So, input-output characteristics of circuits, and the examples of such circuits are transistors. In order to describe the parameters, in order to describe the various characteristics of transistors, we will be going for the H parameters. Okay. So now, here these are the mathematical relations. So now we can also express this in terms of matrix as V1, V1, I2 are the dependent variables. So V1, I2, this is a column matrix, and H11, H12, H21, H22, I1, V2. Now this is the H parameter circuit of two-port network. So now how to calculate this one? So we already know that the relationship between voltages and currents in H parameters can be represented as this, right? V1 is equals to H11 into I1 plus H12 into V2, and I2 is equals to H21 into I1. This is I1, this is I1 plus H22 into V2. So now let us short circuit. So here now we have, what are the parameters we have? Independent parameters what we have? I1, V2. So that means once we have to make I1 as equals to 0, and in other case we have to make V2 is equals to 0. Making I1 is equals to 0 means input open circuited. Making V2 0 means output short circuited. So that is why these are mixed parameters. That means in order to calculate these four parameters, once we have to open circuit the input port, and once we need to short circuit the output port. Now let us short circuit the output port. Now if you short circuit the output port, making the voltage 0, so this is the equivalent circuit of the two-port network. So what we have only V1, I1 and V2 is equals to 0. Now let us find, so we have the equations. What are the equations? That is V1 is equals to H11 into I1 plus H12 into V2, and similarly I2 is equals to H11 into I1 plus H21 into I1 plus H22 into V2. Now what I am doing? I am making V2 is equals to 0. Now from equation 1, what we can have? If V2 is equals to 0, V1 is equals to H11 into I1. So now I can define H11 as V1 divided by I1. So what is this? When it is V2 is equals to 0. And similarly from equation 2, what we can have? As V2 is equals to 0, this becomes 0. So now what we can have? I2 becomes H21 into I1. So H21 can be given by I2 divided by I1 when V2 is equals to 0. Right? So here this is the these are the two parameters that we can calculate from the above two equations by short circuiting the output port. So the first parameter is V1 divided by I1 when V2 is equals to 0. So what is V1? Input voltage divided by input current. So means what? It is defined as the input impedance when output port is short circuited, and it is represented with H11. So H11 is referred as the short circuit input impedance, or else input impedance when output port is short circuited. Similarly, we can also calculate one more parameter from the by making V2 is equals to 0. That is I2 divided by I1, which is given by H21 when V2 is equals to 0. What is I2? Output current. I1 input current. That means it is defined as a ratio of output current to the input current, and hence we can call it as current gain, or else we can also call it as forward current gain. Forward current gain or current ratio, or current forward current ratio, because it is measured between the output current to the input current. It is in the forward direction. So that is why forward current gain or forward current ratio. So it is also called as short circuit current gain or else short circuit current ratio. That is, we are short circuiting the output port. So now let us open circuit the input port. So that means what we are doing, we are making I1 is equals to 0. Now from equation 1, what we will get, V1 is equals to H12 into I2. So that means H12 is equals to V1 divided by I2 by making I1 is equals to 0. So this is the equation. Okay. I hope it is V2. I hope it is V2. So we have the equations. V1 is equals to H11 into I1 plus H12 into V2, right? So similarly, we have I2 is equals to H21 into I1 plus H22 into V2. So now what I am doing, I am making I1 0. So this term becomes 0 and this term becomes 0. So H12 is equals to V1 divided by V2. V1 divided by V2. So what is the ratio here? It is the ratio between the input voltage and the output voltage. As it is a ratio of input voltage to the output voltage, we can also call it as reverse voltage gain by open circuiting the input port. So this is referred to as a reverse voltage gain because this is a ratio which is measured between the input voltage to the output voltage. But the voltage gain is always defined as a ratio of output voltage to the input voltage. You always remember, gain is always calculated from output parameter to the input parameter. As it is calculated in reverse, so we are calling it as reverse voltage gain. And similarly, we can also calculate one more parameter, which is from the equation 2 by making I1 is equals to 0. That is I2. What is the second equation we have? I2 is equals to H21 into I1 plus H22 into V2. So we can calculate H22, which is equals to I2 divided by V2 by making I1 is equals to 0. So I2 divided by V2. What is this I by V? Nothing but admittance. And what is the ratio it is calculated between the output current and the output voltage. So that is why it is called as output admittance when input port is open circuited. So these are the 4 parameters. So now here, as these are the 4 parameters, so H11 is the input impedance and impedance parameters are there, admittance parameters are there, and also we have voltage gain and current gain. So that is why this is hybrid. These are mixed parameters. So that is why we can call this as hybrid parameters. So these are the equations here, and we can also represent them in the form of equivalent circuit. So if you observe this circuit, this first equation. So what is this one? H11 is nothing but input impedance, which is defined as a ratio of V1 divided by I1 into I1 we have. First term, H11 into I1. So I1 get cancelled. It is equivalent to V1. What about this one? This H12, which is also equals to H12 into V2. H12 is nothing but our just a second. H12 is what? H12 is our reverse voltage gain. So which is given by V1 by V2 by making input ports open circuited into V2. So V2 get cancelled. So that means these two are the equivalent voltages. These two are the equivalent voltages. So as the voltages are applied here, I can see that I can represent the input equation as a circuit which is obeying the Kirchhoff's voltage law. So that is V1 is the input voltage, which is equals to H11 into I1, that is the current flowing through that loop. So what is Kirchhoff's voltage law says? The voltage, sum of voltages in a closed loop is equals to 0. So that means all the elements will be connected in series in case of KVL. So like that, I am connecting all these elements in series because H11 is impedance. So H11 is the impedance. So that is why we are representing this one with resistance here. Whereas H12 into V2, what is the equivalent of this? This is a voltage. So I am representing this as a dependent voltage source. Okay. So that is why it is represented like this, dependent. This symbol indicates that the source is dependent. So H12, what is the magnitude of voltage here? H12 into V2. Now if you apply the KVL here, so minus V1, okay, plus I1 into H11 plus, because the current flowing through this resistance is I1. And what is the resistance represented with, or else impedance represented with? H11. So if I know this, the voltage drop across this one can be given by I1 into H11 plus this is a voltage. So that is H12 into V2. I can write this one as V1 is equals to H11 I1 plus H12 into V2. So this is the first equation which can be represented as a circuit based on KVL. Okay. Similarly, the second equation, which is nothing but currents. Okay. So here I2, what is the second equation? We have I2 is equals to H21 into I1 plus H22 into V2. So these are all indicates the equivalent currents here. So this is admittance. This is my admittance. Okay. This is my admittance. Admittance means inverse of resistance. Admittance. Whereas this is the current source. So this is also dependent because it is depending on the input current. So we are representing this as a dependent current source. The current direction is this, where it is circuit is drawn by applying the Kirchhoff's current law. What is the current law? KCL states the currents entering a node, sum of currents entering a node is equals to the sum of currents leaving the node. So that is why all the elements will be connected in parallel. So this is the equivalent circuit. Now combining these two equations, that means the two equivalent circuits of these two equations, we can have the equivalent circuit, H parameter equivalent circuit of the two-port network. So this is the H parameter equivalent circuit. So this represents our input port, okay, which is represented by V1 is equals to H11 into I1 plus H12 into V2. And this is our output port, which is represented by the equation I2 is equals to H21 into I1 plus H22 into V2. In parallel, voltage is same. So that is why this is the voltage measured across the output port and the current flowing through the output port is I2. So the sum of current, this current is divided here. So as we all know that the voltage drop is V2. So H22 into V2 will be the voltage drop across this one. And this is the current source whose magnitude is equals to H21 into I1. So that is why H21 into I1 plus H22 into I2 is equals to the input current I2. Okay. So this is the equivalent circuit, H parameter equivalent circuit of a two-port network. Right. So now let us see the hybrid parameters. Why we are going for hybrid parameters? So hybrid parameters are real numbers up to radio frequencies, where we are going to analyze where we are going to use this H parameter in order to analyze the various characteristic parameters of amplifiers, where amplifiers are applied with AC signals. Whenever we are applying AC signal, that will have some frequency. So as the H parameters are real in quantity, when up to radio frequencies, we always prefer H parameters, and they can be determined from the transistor static characteristic curve. How we can determine these from the static curve, we'll see in the in another class. And we can easily calculate these H parameters from static curve. So we are going for this, and they are convenient to use in circuit analysis. So these are very convenient to use in the analysis of circuit and design, and easily convertible from one configuration to the other configurations. And these are readily supplied by the manufacturers. So that means the transistors are manufactured by some other companies, right? They will readily provide the values of these H parameters for different transistors, and they are very easy to measure. So these are the advantages of H parameters. So that is why always we prefer H parameters for the analysis of transistor circuits. And coming to the dimensions, that means units of H parameters. So these are mixed parameters, as I said, where H11 is the input impedance. So that is why the units are ohms, where H22 is the output admittance, which is defined as a ratio of output current to the output voltage, and the units for them are mhos, whereas H12 and H21 are transfer ratios. So these are dimensionless because these are measured between two same kind of parameters. Gain doesn't have any units. So that is why either it is a voltage gain or current gain doesn't have units. So that is why it is dimensionless. And based on the names, we can have some other subscription. for our convenience. So as 11 is the parameter, H11 means what? Input impedance. So that is why 11 is replaced with I, because it is measured as measured as a ratio of input parameters. So that is why we are representing it as input, and hence the notation I want to use as I. Wherever I come across 1, I have to use 1 I. Whereas 2, these are the two parameters which are related to the output port. So I want to represent it as O for our convenience. And similarly 2, 1. That means output to the input. So it is forward. So that is why we are considering it as F. Whereas 1, 2, it is defined as a ratio of input parameter to the output parameter. So that is why it is reverse transfer ratio. Right? So that is, with all this notation, I can represent H11 as HI. These are the short circuit parameters. These can be calculated by short circuiting the output port. So that is why HI I can represent. And H21 is HF, which is the forward current gain or forward current ratio. Next, open circuit. These are the open circuit parameters. Open circuit parameters. Input open circuit parameters. So H12 is represented with reverse voltage gain or reverse voltage transfer ratio. H22 is the output admittance. So now the two hybrid parameter model of a two-port network can be modified mathematically as this one. So V1 is equals to HI into I1. In place of H11, I placed HI. H12 HR. HR V2 and I2 is equals to HF into I1 plus HO into V2. Okay, wherever HI means input impedance, HR means reverse voltage gain, and HF means forward current gain, and HO means output admittance. Okay, now based on that, we can draw the equivalent circuit. So this is the equivalent circuit where we have replaced that H parameters with input and output parameters like HI, HR, HF and H0. There is no much difference. Just we have replaced that H11, H12, H21 and H22 with its equivalent H parameters. Okay, general amplifier. How can we construct an amplifier? So we have a transistor which can be approximated as a two-port network. Either the transistor can be any of the configurations. So if I apply input signal whose strength is to be improved at the input port and a load resistor at the output port, then we can convert the transistor as an amplifier. So what we are doing, we are connecting an voltage source, AC voltage source in series with a resistance to the input port and a load resistor to take the output voltage at the output port. We are converting a transistor into amplifier. And coming to the equivalent circuit of transistor, wherever we have a transistor, we need to replace the transistor with its equivalent H parameter circuit. So this is the H parameter equivalent circuit of a two-port network. As I said you that the transistor can be approximated as a two-port network. So we are just replacing the transistor with its H parameter equivalent circuit. HI, HRV2, HF into I1, HO, which is the output admittance. Whereas the remaining circuitry will be as it is. So that is voltage source in series with a resistance, and at the output side we have a load resistance. So you have to remember this is our transistor equivalent circuit where we are approximating the transistor as a two-port network. So now these are the different configurations. So there is no much difference whatever it may be the configuration. Only we are going to add one more subscript, that is E in case of common emitter configuration, B in case of common base, and C in case of common collector. This is common emitter configuration and its equivalent circuit. So as we all know that in common emitter configuration, base is the input terminal and collector is the output terminal. So VB is the input voltage, okay, and IB is the input current, okay, and similarly IC and VC are the output parameters. So that is what we have replaced here. Base is the input terminal, collector is the output, whereas the common terminal is emitter. So the current flowing through the input port is IB and the voltage drop across this one will be VB. This will be VB. And similarly, the output current will be IC And here the output voltage is measured across the collector and emitter, which is represented with Vc. And these are the mathematical equations. Vb is equals to HIE into IB plus HRE into Vc, and IC is equals to HFE into IB plus HOE into Vc. Similarly, for the remaining two configuration, only the thing is we are adding a subscript based on the configuration. So in common base, base is the common, emitter is the input and collector is the output. So base is the common terminal, emitter current IE, and the voltage will be considered as VE, whereas the collector is the output terminal and the voltage will be considered as VC. So these are the equivalent circuits of the transistor in 3 configuration. So these are the various parameters of 3 configurations here. As we all know that in common base configuration, input voltage is VEB and input current is IE. So input impedance HIB can be represented as VEB by IE. And all these parameters are calculated. This input parameter is calculated, input impedance is calculated by short circuiting the output port. So HIE is equals to VBE by IB and HIC is equals to VBC by IB. And similarly, these are for the, this is the reverse voltage gain. Okay. So reverse voltage gain is defined as a ratio of input voltage to the output voltage. In common base, VEB is the input voltage and VCB is the output voltage. And similarly, in common emitter, VBE and VCE, VBC and VAC. So like that, we have various parameters of common base, common emitter, common collector configuration and their formulas. Okay. And here, as I told you that the H parameter values are given by the manufacturer itself. So these are the typical or else ideal values of H parameters for the 3 different configurations of the transistor. In common emitter configuration, HIE value is 1100 ohms. HR value is 2.5 into 10 to the power of minus 4, because this is reverse voltage gain, unitless. So that is why we don't have any unit here. And HF is a forward current gain, which is 50. It is also unitless. Whereas admittance and the value of typical value in common emitter configuration is 25 microamperes per volt. Okay, it is admittance, current to the voltage. So amperes to the volts. And common collector configuration, these are the values. So the formulas and values should be remembered. So these will be used in case of solving some problems. So you have to remember the typical values of all the H parameters of a transistor in 3 different configurations. So 1100 ohms for common collector configuration, HI value, HR value is 1 and HF value is minus 51 and HO value is 25 microamperes per volt. And for common base configuration, HI value is 22 ohms and HR value is 3 into 10 to the power of minus 4. HF value is minus 0.98 and HO value is 0.49 microamperes per volt. Okay. So these are the typical values of H parameters which are provided by the manufacturer itself. And these in practice, the values will be varying. Okay, so the typical values, if we need to consider, these are the list of values of H parameters for all the 3 configurations. Okay, so that's all for today. That's all for this lecture. So in this lecture, we have seen what are the Z parameters, Y parameters, and H parameters, and why we are going for the H parameters, and how to find out various H parameters of a 2-port network. And how can we approximate a transistor as a 2-port network? And what is the H parameter model of a transistor in all the 3 configurations we have seen? And the H parameters of a transistor in 3 configurations, its formulas, and the typical values of hybrid parameters we have seen in this class. And in the next class, we will be analyzing the generalized transistor amplifier. That means we will be calculating the current gain, voltage gain, input impedance and output admittance of a transistor amplifier in the next class using H parameter model. That's all for this lecture. I hope it is clear to everyone. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.